All right, so I'll be talking about CNN, and of course, I will not be going to talk about how to code CNN in R, because it is too short of a time for me to cover those things. But my focus remains to be on the motivations for CNN. That why CNN was created and what are the applications and what are the fundamental principles that goes behind CNN. So that's going to be the focus. So just my bio. I'm currently teaching a course at Caltech on deep learning and TensorFlow, where basically this talk is coming from that course. And there are some flyers lying on the backside as well for this course. If you want, anybody can pick that up as well. So
the flyers are over there.
Right, yes.
I'm sure you grabbed one.
So these are the things about this Caltech course. Okay, so my first question is that, first of all, I'm going to check your eyesight and see if you are able to see something or not. Because CNN, the foundation for CNN is built upon this idea. So what are you looking at?
A little kid.
A little cat, okay? And what are you seeing right now?
Double vision.
Two cats, okay? So now, are you sure that your eyes is gonna actually seeing this cat on the left hand side? So the question really is this, that what is your eye is gonna see and what is your brain is gonna see? They are two different things. Okay, so that's the whole idea. That is the foundation of CNN. Now, I'm sure that you must have remembered this guy, Groucho Marx. So basically he said this thing, that what are you going to believe? I mean, who are you going to believe? Me or your own eyes? He was right. Eyes cannot see anything. What we see is from the brain. Eyes only see the outline of some structure, whereas the brain interprets that thing. And that is the foundation of CNN. So in fact, Groucho Marx was right, that don't believe your eyes, but believe your brain, because brain basically allows you to see these things. So this is what your eye is seeing, only the outline. And also the image that is being formed on the retina is upside down. And you only see a little bit of colors, and that's it. When this information goes to your brain, then the brain basically tries to interpret this image and figures it out. And that is the foundation for CNN. Okay, so now, in fact, this is what your eye is looking at it. And this is what you are seeing. And this is the brain basically sees these things. So how did we figure it out? How do we know that this thing is true? I mean, so unless and until somebody puts some electrodes in the backside of your retina and really see exactly what the eye is seeing. So then only we will figure it out, isn't it? That is the only way by which you will believe what I'm saying. And that's exactly was done in 1970s by two pioneers of the human vision system, which are called the Hubel and Tristan. They also won the Nobel Prize. I'm going to show their work as well. So that's what the human eye is. Human eye basically allows you to capture whatever you have, and then it goes to the brain through the optic nerve, and the brain basically able to figure it out, all these things, not the eyes. Eyes only see the outline. So this work was actually being done by these two guys, which is called, which are the Hubel and Wiesel, and their work basically kind of was started this whole area of CNN. And their work was so important that they were also being honored by a Nobel Prize in 1981. So I'm going to show, and these are those two guys which are on the middle and on the right hand side. These two guys are from Johns Hopkins University, and they won the Nobel Prize on the human visual system. So I'm just going to show you a video, and here is that video, and here is that cat. You can see that cat over here. They actually put the electrodes in the backside of the poor cat, I don't know what happened to the cat, it must be quite painful, but that is the way the things were. And that thing is absolutely true. So we are going to show you actually a video for only 1 minute. It's a 1 minute video, and you're going to see these two guys, Hubel and Wiesel people will be there. And this video, okay, I'm reaching there. I'm just jumping to YouTube now. It's just taking a little bit longer. And it is a 1 minute video. And you will see the actual experiment that was done in 1970. And it's taking too long. Shouldn't happen that way. Let me start from here. Maybe.
Are you connected to the internet?
I think I got disconnected. Just a second. Before I started my presentation, I was connected. Just give me 1 second. Yes, I'm not disconnected for some reason. So no, I'm connected. Yeah, no, I'm connected. Okay, no, I've got that. Okay, now let's try it. Just a second. And here we go. Come on. Either the internet speed is very slow here. Before I started my presentation, I started the video. It was working at that time. And I'm connected to the internet. PS guest. That's terrible. Anyway, I don't want to waste too much time so just to show you the video. But in the video, they have shown that these two guys put electrodes in the backside of the cat, and when they try to expose any kind of an edge, all the rods that we have on the backside of the eye, they basically get excited. I mean, you can start seeing some kind of electronic transmission that is going on from the retina towards the brain. So there was some excitement, and they did for the video in which they are showing it. If you want, you can. If you want to check it out, you can search for the Hubel and Wiesel cat experiment over there. So the issue is, so what was the most important thing they did was that only when the eye is being exposed to an edge, then only we can see something. So as a matter of fact, if I'm looking at something in front of me, all I'm looking at it from my eyes only are the edges. And when these edges, when this information goes to the brain, then the brain is able to figure it out, exactly what those things are. So brain interpretation of those edges allows us to see. That is the foundation of human visual system, which was being discovered in 1971. And finally, they won the Nobel Prize in 1981 for this thing. So this started actually, in fact, a lot of work in the area of CNN. So before that, as you know, we used to have the neural networks. But the neural networks were very, very poor. Means the results that they were getting from feeding the images to the neural network was extremely poor. I mean, the results was just not good. So what they did was that, then they said that, why don't we apply the convolution operation on an image and then feed that thing to the neural network. So what does convolution operation does? It enhances the edges of an image. Those of you who have background in digital image processing or signal theory, you know that if you pass an image through a filter, which could be, so that all these edges basically gets enhanced. So that is the idea. So whenever they were trying to expose these edges on the cat's eye, they used to see a sound. That means there is some kind of activity going on behind the eye. So that is the foundation in which the things basically change. So this was a clue on which how we can build the neural network. So now if we can apply the convolution operation on the image and then feed that thing to the neural network, we are going to get much better results. So that was the idea basically that was started by a few people. In fact, the first person was this guy, Konehiko Fukushima. He tried this idea of applying the convolution operation on an image and then feeding it out to the neural network, and he got some very good results. So that was the started. This area started in 1980s roughly, late 80s. But this idea was only there in Japan because he did this experiments basically in Japan, and he reported that thing. But it was never been used worldwide. And then later on, this whole idea came to the United States, and then here they also started doing the convolution operation on the images, and then they are trying to feed those things in. So these were the three guys, Hinton and LeCun. These also won the Turing Award for their work as well. And so this Turing Award was just announced earlier this year on March 27, 2019. So this is the work they have done basically on CNN. So CNN is the way by which now we have the ability to recognize objects in an image. So now you must be wondering what kind of applications are there for CNN. So in CNN we can have autonomous cars. We can also recognize objects in a medical image. So there is there are a lot of applications there by which we have the ability to recognize the objects. In fact, actually a lot of radiology work can be done by computers now, because there is always a shortage of radiologists, and once these images are being captured on X-rays or whatever kind of a device you have, and you can feed that thing to the computers, and they can able to recognize whatever they are looking for. So that is another major application of CNN. So CNN basically has two major applications: autonomous cars and also medical imaging. So these are the two areas where which is being used very heavily right now. So then there was this lady, her name is Fei Li. She actually graduated from Caltech, and now she is a professor at Stanford. And she started a competition way back in 2010. And she has a kind of a huge database of more than a few billion images, or at least a few million images, or whatever it is. And then she started this competition and said that I'm going to release 100,000 images this year. And let's see which software is able to recognize the objects in those images. So in 2010 that thing happened, and people were able to recognize maybe 60-70% of the images. Then in 2011 it kind of raised that thing to 65%, 70%. Then in 2014 it jumped from 70% almost to 85%. And why this thing happened? Because they started using convolution neural network. And this is the year 2014. That is the year when Google said that autonomous cars will be on the road within a matter of 2 to 3 years. Right after that experiment was successful. So this is the lady basically who started that whole thing. And she has also made a lot of contributions in the area of CNN. So that is basically the motivation and the reason why this whole thing basically started. So now let us look into the convolution operation very briefly. Of course, people who have taken some courses or people have some background, digital image processing or signal processing, they know pretty much what this convolution operation is. So convolution operation is that we apply a filter to an image. And what happens that when you apply the filter, the edges of those images are going to be enhanced. So this is the process that goes into the neural network. We take an image, we apply the convolution operation, we then apply the pooling operation. Again convolution, pooling, and finally we are able to recognize what these objects are. Just because we are applying the convolution operation to the images, these networks are called convolution neural network, or in short they are called CNN primarily. So suppose if this is my image, so let us go very briefly. Suppose this is my image and suppose this is my filter. So I'm going to do, what I will do is that I'm going to pass this filter on top of this image, and then I'm going to slide it through. So suppose this is my filter. So here is my image, and that is my filter on top of it. Then I'm going to multiply all of these elements, the elements that we have on the filter and also of the image itself. So these pixel values, and so these things, so this value in the center of my output image, that is C11, will be computed by, if I multiply filter value with the pixel value, plus filter value and the pixel value, and so on and on. All these 9 operations are going to get done, and I add them together, and that is the value which I'm going to get for my output image. So this process is called convolution, and it is a simple mathematical operation which gets done. And so as you can see, if I'm here, I can move it here. So if this is my image, for example, and if I apply this filter, as you can see, this is a Gaussian filter, I'm going to get this image. So the question really is that what I'm going to get here? What kind of image I'm going to get? So I'm now going to show you some results. So now suppose if this is my image. That's the image of a moon, and if I apply some type of a filter, I can get this image. As you can see, all the edges are now being enhanced. And or if I apply a different kind of an image, I can get even this image as well. And here you can also see these edges are getting enhanced, but in a different way. Or you can make the image very, very sharp. So that's what happens when you apply these filters. So when you apply the convolution filter on these images, the image, all the images, edges are going to get enhanced. So since we are applying the convolution operation on these images, then we have a higher probability that these images can be recognized by the neural network. And why this idea came about? Because of the Hubel and Wiesel experiment. Because they told us that only I can recognizing is actually other edges. Nothing else is going on. It is the brain that basically interprets these things. So what happens that now we have built the cameras. Cameras can capture everything you want to. But we don't have the neural network. Now the neural network is equivalent to the brain, and the cameras are equivalent to our eyes. So our eyes and neural network, so our eyes and brain are equivalent to our cameras and neural network. So of course the neural networks are not as good as the eye so far, but it has reached a very high level of accuracy in terms of recognizing what these objects are. So that's why this thing is called convolution neural network. So now let me give you some other examples. Suppose if I apply some Sobel filter, this is another kind of a filter. If that is my image, see, I'm going to get this image. So and again, how I'm getting this image is because of the convolution operation. Now if I feed this image in my neural network, it will have a tough time in recognizing what the objects are in that image. But this one, now system can recognize much better. Accuracy is much higher. If we feed in, if we are going to feed in the convoluted images to my neural network. So then we also do the pooling. So as you know that we had in our neural networks, we had the convolution operation, and then we had the pooling operation. Pooling operation allows us to compress the image because images are being flattened out and then they are being fed to the neural network. So as you can see, if you have got a 1000 by 1000 pixel size image, that's going to be almost 10 million pixels that we are feeding it in. So we have to compress those images also. So the compression portion basically comes from pooling operation, and pooling operation is very simple. It looks into these 4 pixels, and suppose if this is a max pooling, then the maximum number out of these 4 will be pulled out. Then the stride is 2, so we move two steps here, and then we are going to look into the maximum number out of these 4. So we get 2. Then again stride is 2, so in that case I can move now 2 steps down, and from here I'm going to grab 6, and as you can see I'm going to grab 3 from here. So this 4 by 4 image can be compressed down into a 2 by 2 image. So this is just a very, very simple example of the pooling operation. I see there is a question over there.
So do the numbers represent like RGB values or?
Yeah, there are 3 channels to that. This is a very, very simple example of a pooling, but the pooling basically gets done on all 3 channels.
Okay. Because one in the top left corner is blue, but one is also yellow. So what do the numbers represent?
No, these are just some pixels. This is just a kind of mathematical example. But of course, in a real world, these values are going to vary from 0 to 255. And all 3 channels here. I mean, this is just a simple example to explain exactly what pooling is. Pooling just allows you to do the image compression. But these values in the real world, of course, are going to be from 0 to 255. As you know, I think that you must have had a background in digital image processing. Is that correct?
No.
Oh, you're not doing image processing? Okay, then you should take a course on image processing because it's a foundation for CNN. So now the question comes up is that what are the tools necessary to build? So what are the tools necessary to build these things? So there are many different tools that you can use. So on the back end, of course, you have TensorFlow, you have scikit-learn, Theano, and CNTK, Torch, PyTorch, Caffe, H2O. There are many, many software available. But the most popular these days is TensorFlow. That's the one which is now gaining a lot of momentum. But now TensorFlow is just a library. There is no front end for that. So you can either use R, because since this is the Orange County R users group, I'm going to promote R. You can use R as well. But the most popular one, of course, is Python. Because our TensorFlow library is written in Python. So with Python, usually it works the best. But for R also, it works very well as well. As John said that in March or April timeframe, I gave a talk here on how to use TensorFlow for the neural networks, and there I showed you the example of R. So you can use R there as well. But to use TensorFlow directly is usually much more complex. So there is another piece of software available which is called Keras. So Keras is now becoming very popular because to deal directly with TensorFlow is pain in the neck. So you use Keras for that as an interface software, which makes the life a little bit easier to interface with TensorFlow. So sure, you can use TensorFlow directly, but if you have Keras, it makes the life a little bit easier. Or you can use, you can use Keras with R, you can also use Keras with Python. And there is another one which is also available, which is called Apache MXNet. I have not used it, but that is another choice you have primarily. So these are the tools that are available to basically build CNN. Okay, so now let us very briefly look into the applications of CNN. So now this is the video which I am not going to play this video. It's basically coming from NVIDIA. So as you can see, as the car is moving, car can recognize all of these objects. So when the car moves, it knows how many cars are in front of it, what is the signal light, and how many cars are on the left hand side, how many cars are on the right hand side, and how many cars are there on the back side as well. And so it can navigate properly. So that is, and why and how this thing is happening? Because of CNN, Convolution Neural Networks, but it basically allows you to identify these objects. Now this is your dream car. Now just imagine that this is the way the future is going to be. And there is one thing missing in this image. Can anybody guess what that thing is?
There's no steering wheel.
It's in the front.
Actually, a bottle of champagne is missing. That is something that you can drink. So once these kind of this does not exist at this time, but that's for the future. Right?
So why is she wearing a neck brace?
That is she's a fashion expert. So you should, that is the type of fashion she's doing. It has nothing to do with the neck brace or anything. So, but anyway, that's the way that she chooses to wear. And so just imagine, that is the way the life is going to be. So a few years from now, maybe 5 years, 10 years, 15 years from now, then you're going to sit in these kind of cars, then you should be saying, thanks to Convolution Neural Network. Because of that only these things are happening. Then also in the medical field, as you know, a lot of people have written many books on this subject as well, which is deep learning and convolution neural network for medical imaging. So that is another major application of it. And those of you who are thinking about becoming an entrepreneur, that's a great area to be in at this time. A lot of demand is there, and people will like to use the CNN for these type of applications. So now I think just my time is just over, and then let me just kind of review what I covered. So as you can see that the foundation for CNN came from the Hubel and Wiesel study. That only when we detect edges, I can only see that thing. That was the thing that basically opened up everybody's mind. And using that idea, the convolution neural network was being built. So in convolution neural network, we apply the convolution operation first, and then we feed that thing to the neural network. Because of that, we can identify the objects in an image. And so convolution is an image processing technique. And so the applications are twofold: autonomous cars and medical imaging. That's all. Thank you. Any questions? Yes.
So you were talking about kind of repeating the convolution pooling sequence. Kind of when does that stop and actually feed it into the network?
After 2 or 3 layers almost. First layer is always convolution, second is pooling. We do one more layer of convolution on top of it, again pooling, and then usually we feed those things. There is no science behind it that how many layers of convolution you need or how many layers of pooling you need. Most of the stuff that is being done so far in the industry and also research just by trial and error. So when that competition which I was telling you, which was started by Fei Fei Li, they had 150 layers. First 4 layers were convolution pooling, then they have around almost 145 layers of which were hidden layers. And they had approximately around 2 to 3 billion neurons there in that neural network. So they were able to recognize most of the objects. So that is the way the state of the industry is right now. Any other question? Yes?
What different types of filters are there, and how do you know which ones and how many to use?
Yeah, actually there are 2 kinds of filters. One is called the high pass filter and the low pass filter. If you are electrical engineering background, you know that in the high pass filter, high frequencies basically pass through. So similar to that, we also have sharpening filter and also dulling filter, which can sharpen the image and which can dull the image, depending upon what the values of your filter is. So here we use sharpening filter, and which is called Laplace filter that basically is being used. But there are many different variation of filters you can try. So if you try different variation of the filters, different part of the image will get enhanced. So, but here primarily we are using sharpening filters. And there are tons of them, more than 10 or 15 different types of sharpening filters exist. Any other question? Okay, thank you very much.
Thank you very much.